Good morning. Good morning. Hello, how are you? All right, you're welcome to our today's lecture. We are still on the course BDT 152. BDT 152, Basic Dispensing Theory 2. 201 1. All right, so let's do this. Today is what?
Six.
Thank you. We are still on the topic tablets. And these are 11th contact, right? 11th contact, part 11. We are still discussing tablet coating, right? But we are specifically discussing the coating solution or coating formulation. Yesterday we discussed the components. The component we discussed yesterday was we discussed the film format, right? Specifically, we discussed the non-enteric film formats. Non-enteric film formats. Actually, we just outlined them. Yeah. And we said that in today's class, we pick them one after the other. We talk about how they are manufactured. We also talk about their inherent properties. And if they have one or two issues, we'll also talk about them. And also talk about the need for additives to improve the film, okay? Yeah. So the first one we'll start with is HPMC. HPMC is what? Hydroxy what? Propyl methyl what? Cellulose. So from the name, do you think is a synthetic or semi-synthetic? Semi-synthetic. All right. So now, the available ones are in different grades. They are graded based on their viscosity. So it's available in different viscosity grades, and it is manufactured by reacting alkali treated cellulose with methyl chloride and propylene oxide. So alkali treated cellulose is reacted with methyl chloride and propylene oxide to form hydroxyl propyl methyl cellulose. Now, actually, it's better used with plasticizers. It's better used with plasticizers, because when used alone, it has the issue of producing rough tablet surface. Rough tablet surface, which is not a wonderful product. True of us. So the best is to do add plasticizers to improve the quality of the film, okay? The quality of the film. So it's not encouraging to use it alone. That's the message. Now, another thing I want us to know about this HPMC is that it is cheap, it is flexible, it is highly resistant to heat and moisture. It is cheap, flexible, highly resistant to heat and moisture. And it has no taste, it has no odor. It's tasteless and odorless. So the basic thing there is this. The issue of not being used alone is better used with plasticizers. Almost most of them are like that. But you can always add one or two things, additives, to improve the film. So that's for HPMC. Any question?
What does it mean? What is the dosing of tablets?
You should tell me that because you have this material. You go through it. You have your what is it called? Your Android phone with you. I've taught you about this issue of if you see a word you don't like, you should browse immediately and do what? Go through it. So the first thing you should have done is to go through it. How do you mean you have gone through it now and you're asking me a question like there are some things I don't understand about this what? The boss, right? I cannot talk to you. Based on the existing protocol, I will answer that question. Browse it now and tell me what you saw or what you were able to see from your research. Then we can talk about it. Yes. You have to learn how to do what. How can you be reading the material and you see a word you're familiar with, you not go through it? It doesn't make sense now. Does it make sense? You should go through it now. Check it off. That is how to study. That is how to do what? Study. You go through it. Look at it. Maybe having gone through it, you could not find anything meaningful. And here we can now talk about it. That's why I gave you this material ahead of time. So I am waiting for your answer. What does it mean? What does dispensing mean? Dispensing, tell us. Is what?
Imprinted with a mark below the dosage form surface.
I have mentioned this here, if you can remember. Some time ago. Can you remember?
Yes.
I even explained it. I mentioned it in this class. I even did what? I even explained it. Alright, let's continue. Now, next one is what? Methyl what? Hydroxy what? Ethyl what? Cellulose. Methyl what? Hydroxy ethyl what? Cellulose. MHEC. Now, it's also available in various what? Viscosity what? Grades. And is prepared by reacting alkali treated cellulose. By reacting what? Alkali treated what? Cellulose with what? Methyl chloride. And then what? With what? Ethylene oxide. Who can tell us the difference between the manufacture of MHEC and HPMC? Who will tell us? There's a slight difference.
And HPMC is prepared with propylene oxide, while MHEC is prepared with ethylene oxide.
Basically, both of them, you react treated what? Alkali treated what? Cellulose with what? Methyl chloride. Then where the difference lies in what?
Propylene oxide and ethylene.
Propylene is for what? Why ethylene is for what? Ignore this slight what? Differences. Alright, so it has what? Similar properties with as what? The only difference is in what? This MHEC is soluble in fewer organic solvents, while HPMC is soluble in more wider range of what? Organic what? Solvents. So this one is what? Soluble in what? Fewer organic what? Solvents. Because of that now, it is not used frequently as what? HPMC. It's not frequently used as what? HPMC. Of course, now, just as we discussed in HPMC, you also add other what? Polymer, okay? To be able to do what? Improve the what? Quality of the what? Film produced, okay? Now, the next one I want us to talk about is what? EC. Ethylene what? Cellulose. Ethylene what? Cellulose. Is it MHEC and EC, are they synthetic or semi-synthetic? Now let's look at EC, ethylene what? Cellulose. Now, you know, in this reaction of semi-synthetic production of this thing, of all these things I've mentioned, there's always this ethoxys of ethoxy. You're going to say, did you do where did you stop in your organic chemistry? In your organic compound,
Homologous series.
Have you actually done functional groups?
Yes.
Different functional groups?
Yes.
We already talked about anything about how to do ethoxy. So if I say ethoxy substitution, you know what I'm talking about, right? You did arcane now, you know what substitution reaction is, right? So when I say ethoxy substitution, you know what I'm talking about, right? Good. So let us not waste our time here. So that's why you are doing organic chemistry. So let me do what? Fire on. Now, so in this semi-synthetic production, there's always this ethoxy what? Substitution. Are we together? So for EC, depending on the degree of the what? Ethoxy substitution, we have different grades are what? Available. Different viscosity grades. This viscosity has a lot to do with the degree of the what? Ethoxy what? Substitution. Am I communicating? So depending on the degree, to give you different range of what? Viscosity what? Grades available. Remember, these grades available in the market has a lot to do with what? Their viscosities, okay? Now, this is manufactured by reacting ethyl chloride with cellulose dissolved in what? So cellulose dissolved in sodium hydroxide. What it is? Is it alkaline treated?
Yes.
Is it alkaline treated?
Yes.
Is sodium hydroxide alkaline or acidic?
Alkaline.
So and you say that cellulose is dissolved in what?
Alkaline.
So is it in sodium hydroxide? So cellulose dissolved in sodium hydroxide. Is it alkaline treated?
Yes.
Yes,
sir.
We are discussing chemistry now. This is not chemistry class, but I'm just going back a bit to help you understand what we are doing. So you don't do what cram, okay? So I say that this ethyl cellulose is prepared, manufactured by what? Reaction between ethyl chloride and the cellulose dissolved in what?
Sodium hydroxide.
Good. So now this one, if you don't plasticize it, if you don't add plasticizer, it will only to form a what? Brittle what? Film. It will form a what? Brittle what? You know what? When something is what? Brittle, right? You know what it means? It's prone to what? What is brittle? Can it break easily?
Yes.
There's no fluidity. Alright? There is no what? Just look at plastic now. Just get plastic now. Get your plastic. I think I discussed this in 151 with you. Plastic. Get your plastic buckets. If you check flower vase that are made of plastic, that have been outside for a long time, go close to it, touch it. It will do what? The fluidity is gone. The plasticizing property is gone. The plasticizing property is gone. It will become what? Brittle. Am I completing? Just touch it, it will just break. Now, this is what we mean by when EC is unplasticized EC will always give you a what? A brittle what? Film. So it requires to be modified, okay? By what? Plasticizing, okay? Yes. For it to get the acceptable film of what? Interest. The film of what? Interest. Okay. It is water insoluble. It is what? water insoluble. And because it is water insoluble, it cannot be used alone for tablet coating. So because of that now, it's usually combined with water soluble additives. Am I committing to work on the solubility? Are we together?
Yes.
Are we together?
Yes.
Good. So you can see a combination of EC and H remember I said that HPMC, is it water soluble?
HPMC.
Yes.
HPMC.
Yes, is it?
Yes.
Yes. It's resistant to what? Moisture.
Yes.
Now, the point there is that it can mix with water, but its structure is not what? Destroyed. I hope you know. That means, I hope you know. When something is water resistant, what does it mean? Even though, yes, it cannot be what? Degraded. True of us, water cannot attack it for it to do what? Degrade. Am I communicating? Good. You know sometimes, something can dissolve in water. You know that dissolution is a physical, we are going back to chemistry again. What type of property is dissolution? When something is dissolved in its solvent,
Physical property.
It's a physical change, right?
Yes.
Is it reversible?
Yes.
Is the chemical component of the thing affected?
No.
That's why you can recover it, true of us, because it's not destroyed, chemical reaction. But if you react with it, if water attack it, it will be destroyed, true of us, to form another thing, true of us. But if it's not destroyed in water, what happens? It may dissolve. And you can still do what? Recover it, true of us. That sodium chloride, are we together? Yes. That sodium chloride dissolves in water. Does it destroy the sodium chloride?
No.
It's soluble, but it's not destroyed. True of us.
Yes.
You can recover it.
Yes.
Good. So let's continue. So a combination of what? EC and HPMC is used to prepare film with reduced soluble what? Properties. And this is commonly used for what? Sustained release what? Coating. EC what? H what?
HPMC.
H what?
Yes.
PMC combination are normally used for what? Sustained release coating. If you know, you know. HPC.
So this is
Yeah, it's a mistake. That is easy, okay? Okay, now, so HPC. HPC is what? Hydroxy propane what? Cellulose. Now, this is manufactured by what? Treating cellulose with sodium hydroxide. So if you treat cellulose with sodium hydroxide, is that cellulose alkali treated?
Yes.
Is it alkali treated?
Yes.
Good. So we have used three different. We have expressed this in three different ways now, so you understand what we are saying. Okay, now I said that the HPC is manufactured by the treatment of cellulose with sodium hydroxide, followed by what?
The
reaction with what? At what?
Elevated temperature and
Pressure. At elevated what?
Temperature and pressure.
Hydroxy propane what? Cellulose. Hydroxy. What was the first one we? The first one is hydroxy what? Hydroxy propane methane cellulose. This one is how? Hydroxy. Hydroxy propane cellulose is prepared by what? Reacting alkali treated what? Cellulose with what? With what?
Propylene oxide.
Propylene what? Oxide. At elevated what?
Temperature.
Note the difference between this and the hydroxyl, methyl. What is the difference? Look at them again. You treat that one with methyl chloride first. You treat HPMC with methyl chloride first before treating with what? Propylene what? But here there's no methyl chloride. You just treat the what? Alkali treated what? Cellulose with what? Propylene what? Oxide directly and get your what? HPC. Now it forms a tacky what? Film. It forms what? Tacky what? Film. By tacky we mean that the film is somewhat what? Sticky, okay? Somewhat what? Somehow what? Sticky. So it forms a what? Tacky what? Films. Again and again, it's also used in combination with what? Other polymers to improve it what? It's also used, what is this? What is the name of this? Pack it well. Pack it well now. Have you done that already? Huh? Alright, let's continue. So, is it in combination with what? Other polymers to do what? Improve film what characteristics. Now listen carefully. Is soluble in GI fluids are the many polar organic solvent. Do you know what polar organic solvent means? There are organic solvents that are polar. Alcohol, is it organic solvent? Is it organic or inorganic? Is it polar? When something is polar, what does it mean? Water soluble, right? Yes. It can interact with water freely, right? So, alcohol, is it organic? Is it polar? It has OH group, so it's polar, right? So, when you say polar organic solvent, you talk about organic solvent that are what? Polar that are what? Indeed interact with water, mix with water, possibly dissolve, true of us.
Yes.
But water is polar. Is it organic or inorganic? Water, is it organic or inorganic? Eh? Someone said organic. Is water organic or inorganic? Hey, chemistry. Ethanol. What is the formula for ethanol? See what? See what? Hate what? Hate what? What else? Then water exists, right? Both of them are what? Polar, right? This is what? Organic or inorganic? Organic. So, you now understand what we mean by what? Polar organic what? Solvent. So, this HPC is soluble in what? GI fluids and what? In many what? Polar organic solvent. Now, but when it comes to water, it depends on the what? Temperature. Below 40 degrees Celsius is what? Is what? Soluble in what? Water. But above what? 45 degrees is what? Insoluble in water. Please know this point, okay? It's soluble in GI fluids, soluble in many organic what? Polar solvents. But in water, our temperature below 40 degrees Celsius is what? Soluble. Is what? Soluble. Above 45 degrees Celsius is what? Insoluble. Now, the next one is what? Povidone. 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 Povidone is what? Synthetic. Okay? Povidone is what? Synthetic. It's just a synthetic. It's a polymer of what? 1 vinyl what? 2 pyrrolidinone groups. So the monomeric unit is what? 1 vinyl what? 2 pyrrolidinone. 1 vinyl, 2 pyro what? Pyro what? Pyrrolidinone. So this is the monomeric unit. So it's just a polymer of this group, okay? Yes. And it's what? It's what? Synthetic. Is what? Synthetic. Please note this point. Is what? Synthetic. It has different molecular weight depending on the degree of the what? Polymerization. You know what polymerization is now, right? Have you done it? Have you done it in your 112? You know polymer. You know carbohydrates. Yes. Starch is a polymer of what? Of what? That's some dumb one. Polymer of what?
Polysaccharide for carbohydrates.
Is starch a polymer? So what is the monomer? What is the monomeric unit?
We don't know it.
It's not monomer that will come together to form a what? Polymer, right? So what is the monomeric unit of starch? If you get starch now and keep breaking it down, what is the fine? What is the simplest unit you get? Huh? Hey, it's not true. You know it. I say it. So if glucose come together, glucose, they form dextrose, right? Come, what do they form at the end? So if you break down starch, what do we get at the end? Hey! Sugar is sugar. Sugar, right? Sugar, right?
So we got it.
See, do you know the issue here? You see, I want to. There's another aspect of what study I want people to learn. See, if you study, try to. You know this thing, but the issue is that you have not actually brought it to life. You know it. You have read them, but you are not actually, make it real. Am I communicating? Try to bring it to, try to relate it to what is actually what happening. You know glucose. You know that if you break down starch, you get it. But I just threw simple questions now. I became confused. So study beyond passing your what? Exams. That's the watchword, okay? That's the message this morning. Study beyond what? Passing your exam. Study beyond passing your exams. It's very important. So, what did you find out? So do you know how that glucose is the monomeric unit? Monomer, polymer, one. Smallest what unit, right? It's the monomeric what unit. Are we together? Yes. Good. Now, for this povidone, the monomeric unit here is what? Is what? 1 vinyl what? 2 pyridone group. Now, the point there we want to make here, I want to make here is that you know that since monomer come together, 1 monomer, 2 monomers, 3, the same unit, the same monomeric unit keep coming together to form a long chain, true of us. Yes. Now, what means that as the molecular weight of the polymer that will form will now depends on the what? The degree of the what? Polymerization. True of us. The more monomeric units that come together to form a larger what? Polymer, the more the molecular weight. True of us. That's why they say here that the degree of the polymerization decide the molecular weight of the what? Material. Am I communicating?
Yes, sir.
Am I communicating?
Yes.
Then the grades available also depend on the what? The viscosity. The viscosity. She knows the right thing to do. Please let us always do the needful, please. All right, now. So I say that it's what? Synthetic, right? It's not semi-synthetic, it's not natural, it's what? Synthetic. It is clear, glossy, and what? Forms what? Hard films when what? Dry. So when dry is what? It forms hard film. It what? Glossy. You know when something is glossy, right?
Yes.
Good. And it's what? Clear. So it gives, so the film, the sum is that the film from this, the film formed from this is what? Clear, glossy, and what? Hard. Good. So it also forms tacky what? Films. But this can be overcome by adding what? Plasticizers or other what? Polymers. Now the next thing I want to talk about is what? Sodium what? Sodium CMC is what? Sodium carboxy what? Methyl what? Cellulose. Sodium carboxy what? Methyl cellulose. Sodium carboxy what? Methyl cellulose. Sodium carboxy methyl cellulose. This is available from them. From them, do you think it's synthetic or semi-synthetic?
Semi-synthetic.
Because there's cellulose, there are two of us.
Yeah.
Let's continue. So, this one is what? Available in what? If you have medium and high and even extra high what? Viscosity grades. We have medium, high, and extra high viscosity what? Grades. Now listen carefully. This can easily be dispersed in water to form a colloidal solution. You disperse it to form a colloidal. You did colloid in your chemistry. Secondary school chemistry. Yes. Colloid. It forms a colloidal solution when dispersed in what? Water. But it is what? Insoluble in what? Most. Because it is insoluble in most organic solvents. Because it's insoluble in most organic solvents, it's not the best choice for what? Coating what? Solution. It's not the best choice for what? Coating solution. Because the greater percentage of solvents in making coating solutions are organic. Am I concluding? I'm giving you the reason, okay? Greater percentage of solvents for coating solution, greater percentage are what? Organic. Am I concluding? So because it is insoluble in most organic solvents, it is not what? The material of choice for what? Coating what? Solution. Remember I said that when dispersed in water, it forms colloidal solution. She knows the right thing to do. She just came straight and sat here. That's good. But she seems unhappy. Child. You have no choice. And I'm looking for some other person that will change his or her position. Now, it also gives a what? Tacky what? Film. It also gives what?
Tacky film.
Peg is what?
Polyethylene glycol.
Peg is what?
Polyethylene glycol.
Polyethylene glycol. I wouldn't talk much on this, okay?
Yes.
Yeah, it had high molecular. We have the high molecular weights and the low what? Molecular weights. The high molecular weights are what?
900 to 8,000.
Why the low molecular weights are between 200 and what?
600.
We discuss this peg more when we enter what? Suppository. Okay? We discuss this well when we enter what? Suppository basis. We'll talk about it more there. So let us not talk much on that, okay? But the lower molecular ones at room temperature are used as what? Plasticizers. The lower molecular ones at room temperatures are used as what? Plasticizers. Now let's look at, remember what we've been discussing, film formers, the non-enteric ones. Now let's look at the enteric what? Film formers. Let's look at what? Enteric what? Film formers. Enteric what? Film formers. So I will list them, then take them one after the other. The first one is CAP. CAP is acronym for cellulose acetate. Amen. Cellulose acetate what? Phthalate. C'est moi. God bless you. That P is silence, okay? That P there is what? Silence. Alright. Cellulose what? Acetate phthalate. Okay? Alright, so the next one is what? Acrylate what? Polymers. Followed by what? Hydroxy what? Methyl. HPMCP. Hydroxy propane methyl cellulose phthalate. Then the last but not the least is what? Polyvinyl what? Phthalate. Now, let's. Okay, you want to see phthalate or phthalate? Phthalate. Are you okay now? Phthalate. Now let's look at what? CAP, okay? CAP is widely what? Used. Enteric film former. It's a widely used what? Enteric what? Film former. It is hygroscopic and relatively what? Permeable to moisture and what? Gaseous fluid. It is what? Hygroscopic and relatively what? Permeable to moisture and what? Gastric what? Fluid. Now listen carefully. The film formed using this is that what? Brittle. They are what? Brittle. So they are formulated with what? Hydrophobic film forming materials. Due to that, they are hydrated with what? Hydrophobic what? Film forming materials. To achieve what? Better enteric what? Films. To achieve what? Better what? Enteric what? Films. Better what? Enteric film. Yeah, these coatings are aqueous and enteric what? Coating. I wouldn't talk much on that for now, but I want to just let you know that there's what is called aquateric. Aquateric what? Aquateric what? From the aqueous and what? From aqueous and what? Now, actually, our aquateric coating is actually a reconstituted what? Colloidal dispersion using latex what? Particles. Of what? Latex what? Particles. Are we together?
Yes, sir.
Why we mention this is that this cap is a component of this what? Aquateric coating, okay? This cap is a very important component of what? Aquateric what? So that's why we mentioned it here. So the point there is that this aquateric coating is composed of what? Composed of what? Spheres of cap, either as what? Solid or what? Semi-solid what? Polymer. Spheres. You know what a sphere is, right? Spheres of what? Cap, either as what? Solid. You came in now. Almost 8 and you're going out. No remorse. There's something that I don't understand with that. Hello, hey. Your life. Your life. Seriously, I don't understand. Someone came into a class. 18 meters by 8. And you're going out. How does it sound? Our lecture is about to end. You're going out. All right, so let's continue. So I said that this aquateric coating is composed of what? Calf, right? Spheres of what? Calf. Either as what? Solid or what? Semi what? Solid polymer. Now, the size ranges from 0.05 to 3 micron. In average, 0.2 micron. 0.2 micron. Huh? What is micro? You asked me about what's micro. Nice one. I must teach you how to research. Check it out. Okay, you've already something now. Nice one. She's exposing herself. She said that we are not up to this level. My book is hard. All right, so let's continue. Now we have what? Acrylate what? Polymers. Acrylate what? Polymers. The brand name available for this acrylate polymers, we have what? We have what? Eudragit. You don't have brand name, okay?
Yes, sir.
Just a what? A brand name. So there are two forms available. Eudragit what? And what?
Yes.
And what? S. Okay. Now the L form is available as what? Organic solution, solid or even aqueous what? Dispersion. It's available as what? Organic what? Solution. Or what? Aqueous what? Dispersion. YS is available as what? Only as what? Organic what? Solution and what? Solid. Organic solution and what? Solid. Now, the only difference is that, thank you. The only difference is that L is available as what? Aqueous what? Dispersion. Aqueous what? Dispersion. While both of them are available as what? Both solid and what? Organic what? Solvent. Are we together?
Yeah.
Good. So, both of them, they are soluble in where? Intestinal fluid. pH of 6, 7. So, if they are soluble in the intestinal fluid, what do you think? What message did it pass across?
They're not very good.
So that means they can easily be used to target the what? Intestinal what? This thing. True of us. Intestinal what? delayed what? Release. True or false?
Yes.
Because when they get to intestinal fluid, they'll do what? They'll do what? They become what? They can disintegrate that. True or false? True or false? Because they are soluble in where? Intestinal wall. This has to link points up. You understand what you are doing. You don't need to cram anything here. What you built upon what you built on what already existing what protocol, and keep going, keep growing. We mentioned this from the beginning. Remember from the 451 we talked about reasons for what?
Converting jobs.
So, and all this while we'll be mentioning what happened between the gastric fluid and what? Intestinal fluid. Now we've now gone into what? Into what? Feel what? And now talked about these different forms of what? Hydragit. The one that is, both of them are what? Soluble in what? Intestinal fluid. At that high what? pH. At that high what? pH. Okay, now hydragit what? L and S, they are what? They are actually what? Copolymers of what? And what? Organic chemistry. Try. They are polymers of what? Acrylic and what? Met acrylic what? Acid esters. You know what esters are, right? Is that what? Because you have done it where? Okay. So they are copolymers of what? Acrylic and what? Met acrylic acid what? Esters. Can you see delayed action there?
Yes.
Can you see delayed action there? Yes. So if you're not asked, a question may come like this that you can use it for delay release. You don't need to be told that it can be used, right?
Yes.
Even by mentioning that it's dissolved, it's soluble in what? Intestinal fluid should tell you that. Even without mentioning it here, you should be able to know that it's used for what? Delayed action what? Delayed action what? Formulation. Am I completing? Remember, you delayed its release. Instead of being released here in the what? Stomach, it will not release in the what? Intestine. Good. So these films produce the films produced with this are pH independent, okay? And they have what? Delayed what? Action. This is similar to that of what? EC what? Formulation. What is EC formulation? What is EC formulation? Ethyl what? Formulation. Good. Now I want us to treat HPMC and PVAP. When we are done with that, in our next class, we will not enter solvents. Okay? We will not enter solvents. We talk about different solvents. Okay. So for HPMCP, what is HPMCP? Hydroxypropyl good. Hydroxy what? Propyl methyl. God bless you. So this is derived, listen carefully. This is derived from what? HPMC. HPMC is what? It's derived from HPMC by esterification with phthalic and what? And hydride. By esterification with what? Phthalic what? And hydride. So that is what we now add the phthalates. Okay? This esterification will add the what? Phthalates in what? HPMCP. Am I completing? So that's what will add that what? And that phthalate is from where? Phthalic what? And hydride. Are we together?
Yes, sir.
Good. They are stable. They are more stable than CAP. They are more stable than what? CAP. What is CAP? Okay, so they are more stable than what? CAP, and dissolve at lower pH compared to what? CAP and acrylate what? polymers. I don't like this noise. Alright, so let's continue. We are about to end this class. So I said that they are more stable than what? Cap and dissolve at a lower pH compared to what? Cap and what? Accumulate what? Polymers. Now, this solubility, their solubility helps in what? Helps in what? Increasing the bioavailability of what? Some drugs, okay? Increase in what? Higher what? We have discussed bioavailability, right?
Yes.
You know what it means, right? You know what it means, right? Good. So, because of these solubility characteristics now, some specific drugs, their bioavailability will what? Improve or gives higher what? Bioavailability of such drug when used in coating such what? Remember one of the reasons why we coat. It helps in what? Bioavailability to true of us.
Yes, sir.
Good. So it enhances what? Bioavailability. Now it's available in different grades. We have HP55, HP550, and what have you. What is PVAP? Polyvinyl what? Polyvinyl what? Are you sure? Someone said acrylate. Polyvinyl acetate what? Phthalate. Now, hello. This is manufactured by the esterification of partially hydrolyzed polyvinyl alcohol with phthalic what? Anhydride. It is produced by what? Esterification of partially what? Hydrolyzed what? Polyvinyl what? Alcohol with what? Phthalic what? Anhydride. In terms of stability, is similar to what? H what? Specifically, the one of HP55, the grade of what? HP what? 55. And is what? pH what? It has pH dependent solubility. It has pH dependent what? Solubility. So this solubility is pH what? Dependent. Remember what we said about HPMCP, where at low what pH is what? It dissolves. Are we together? Yes. So that means HPMCP solubility is pH what? Dependent. There's one we mentioned here that its solubility is not pH dependent. What's that? That's what we mentioned now, few seconds ago, that its solubility is not pH dependent. Acrylic what? The Udragit, right? Good. Alright, so we'll stop here. In our next class, we'll continue from what? Solvent. We look at what? Solvent. In our next class, we look at what? Solvent. Any question? Any question? Alright, in the absence of questions, we stop here. No. Alright, we'll stop for now, okay? I'll thank you very much for your attention. God bless you.